Hi everyone. In this session, we are going to learn a very interesting filter or filtering technique known as bilateral filtering technique. So you guys are thinking that maybe you are thinking like that, why I'm introducing you so many filters. For each filter that we have already discussed, like Gaussian filter, then image averaging, then median filter or median blurs. So these all of them have some specific purposes. Well, this bilateral filtering also has a special purpose that here we try to remove the noises, but keeping the edges sharp, right? So it is very important, and it also helps in the case of later stages like segmentation of the images. Okay, so the function we are going to use is CV bilateral filter. Remember, this is the function CV bilateral filter, B small, F capital. Okay, but without gap, you have to write like this CV bilateral filter. And I already told you that this is very effective while keeping the edges sharp, right? But the operation is a bit lower, sorry, slower. Means if we compare with the other filters, obviously this bilateral filter is a little bit slower. And why we have to go for it? In case of Gaussian filters, Gaussian filters remove the noises. Okay, but it is okay, but and also it is comparatively fast. But thing is that it also smoothes the edge, or you can say edges are also being removed. So why it happens? Because Gaussian filter takes the neighborhood around the pixel and finds its Gaussian weighted average. And this Gaussian filter is a function of space alone, that is nearby pixels are considered while filtering. So it doesn't consider whether pixels have almost the same intensity. It does not consider whether a pixel is an edge pixel, means edge pixel, or not. So it blurs the edges also, which we don't want to do, because we don't want to do the blurring on the edges, because if the edges are blurred, then how could you specify some object, or how could you isolate some objects in that particular image? Suppose it is a tumor image, means if it is a MRI image, we need to locate or isolate the tumor. Then in such cases, if you go for applying this means Gaussian filtering, then that is not going to work. For that purposes, bilateral filtering can do a little bit more effectively than the other filters, right? Well, you got to know that where in which situations we have to go for these bilateral filters. Now, these bilateral filters, let me, okay, bilateral filters also takes a Gaussian filter in space, but one more Gaussian filter, which is a function of pixel difference. The Gaussian function of space makes sure that only nearby pixels are considered for blurring, while the Gaussian function of intensity difference makes sure that only those pixels with similar intensities to the central pixel are considered for blurring. So it preserves the edges, since pixel edges will have large intensity variation. I hope you already familiar with that. Which particular means what is the definition of edge, or in which cases we can call that these are the pixels which are forming edges. Yes, those pixels was means intensity variation is at peak. Intensity reached to a peak level, right? Changes or variation is very high. Then in such cases, edges are formed. So this bilateral filtering preserves the edges. Now let's come to the coding part. Import CV to SCV. From matplotlib, we are importing pyplot as plot, and image CV imread, where we are showing the location. We are entering the location, the exactly where the image is located. Here we are considering the linear image. If not found, this message file could not be read. This message will be printed. Now, this is the main thing where we are applying the bilateral filter, that is CV dot bilateral filter image, and specifying the dimension 9, 75, 75, and it is kept in the variable blur. Then two subplots, right? So first one, we are showing the original image, and the second one, we are showing the bilateral filtering. Well, you know about X ticks and Y ticks, and then we are showing that plot. Well, let me show you the implementation part in the Spider. Well, you can see here, this is the code we have written in this particular file, bilateral filtering.py. PY stands for Python. Exact code I have already defined and explained. So this is the blur that is assigned CV bilateral filter image 97575. Well, then after that, let me run this file. Wait. Okay. See, this is the output. This is the original image, and this is the bilateral filtering. Definitely, if you compare these two images, you will find that this one, this smoothing is really doing a great job because the edges are preserved. Remember, in one of the last lecture, I told you that how the edges are also being smoothened with the noises, right? But we don't want that. We want the edges to be preserved so that we can isolate the objects, different objects in that image. See, in this case, clearly the edges are preserved. So it is a very wonderful filtering technique. I suggest that go for it if you want to do your isolation of the image objects in an image, or you can say location, or means finding some objects in an image. Well, in such cases, for the pre-processing tasks, you can use this, right? In some cases, post-processing also you can go for it, but mostly you can go for this means filtering technique as a pre-processing part for the segmentation process. Well, if anything more you'd like to know, then let me know for comments. That's all for this session. Thank you very much. Bye-bye.